us know that there is a lecture series going on microcontroller 8051. Now this is the lecture number 4. Those who are looking into this lecture, please go and see the previous lectures, so they will get some link. Now in this lecture we are going to discuss some features and block diagram of 8051. The 8051 is a basic microcontroller. So once you get that, you can go and extend your knowledge for other microcontrollers. You can go for PIC microcontrollers, you can go for Renesas microcontrollers. Okay, so the most important features, as we know that 8051 provides us a single chip solution, right? So single chip, actually what I have drawn here is actually inside a single chip. See here, I am just drawing one boundary here. That boundary will give us an idea that what is there inside a chip. See, the dotted lines, the black line tell me that this is inside the chip 8051, and what is coming out are the pins. Okay, so there may be pins for different purpose. Now why pins are needed actually? See, how will you can say talk with microcontroller? So pins is the way you can talk with the microcontroller. For example, you want to interface LED bank or display, some sort of thing. Why you need to interface display LED bank? Because you want to see the output. So you will use these ports. These are the 4 parallel ports, I can say. Suppose your microcontroller needs to communicate with personal computer or any other microcontroller, then you will need a serial port pins. Okay. You want to count some pulses. Suppose your project is count how many persons are entering into a particular function. So you need some counter pulses, and those are actually given at the counter inputs. Sometimes you want to interrupt the microcontroller. Now we'll talk very much detail on the interrupt topic. Actually, interrupting means see, microcontroller is doing some task and you want microcontroller to do some another task. So how will you interrupt? So there may be some external interrupts, there may be some internal interrupts. We'll discuss in detail on that when we will be discussing on the topic interrupts. But these are external interrupt pins here. Now why these pins are there? To connect an external crystal here. Why to connect the external crystal? That will decide the frequency on which this microcontroller will be working. Okay, so these are all different pins, and inside there are different blocks. Now the most important block is the CPU. Now what is CPU? As we discussed from the first lecture, that ALU plus control is CPU actually. Okay, so control unit can understand your instructions. Now where you will write the instructions? Instructions will be here. Why wrong? See, when we are talking of the embedded systems, programs are fixed. Okay, so programs are not going to change. So we'll store those programs in this type of memory here. Now of course program will be in the language of ones and zeros. Now these programs will come here and the control unit will understand and execute instructions one by one. Now how much will be the size of this memory? It is a 4 kilobyte. Now what is byte? See, each standard location of memory will be 8 bit. This is a standard location of memory, that will be 8 bit. So 8 bit is a byte. Now suppose there are approximately 4000 locations like this. Now not exactly 4000, because see, 1 kilobyte is actually 1024 bytes. Okay, this is exactly. Now 4 kilobyte will be how much then? You have to multiply 1024 by 4, those mini locations. But for now, let us assume there are 4000 locations. So that's why I have written here 4K. So 4000 bytes. So this way, these are the bytes. Consecutive bytes will be there where we can store our program, permanent data, and so on. We'll discuss in the coming lectures about that. So this size is here, 4 kilobyte. Then why RAM is needed? Because every time you don't need permanent, sometimes you need some temporary storage of data while your program executes. For example, you may need a stack memory. So that will be here in the 128 bytes. See, RAM size is very less, ROM size is very large. Exactly opposite of that is what happened in personal computer. In personal computer, you will see RAM is more, ROM is less. Why? Because we have changing programs, we have multiple tasks, so RAM is more. Even your OS will get loaded in RAM and all that. But here the programs are fixed. So the fixed programs will be stored in the this type of memory, and temporary storage will be here, and that will be less, 128 byte only. Here it is 4 kilobyte. So this is important feature, how much RAM is there, how much ROM is there. Then what are the timers? See, timer is like a clock, we can say. Suppose you want to perform two tasks, and in between those two tasks you want some delay, so you can set a timer accordingly. So there are two timers here, each will be 16 bit. We'll discuss. See, on every part we have a separate, you can say, lecture or separate chapter. So there are two timers. Sometimes timers can work as a counter when if we are feeding the pulses from outside world. So anyway, these are the counter inputs. So there are two timers, it will be 16-bit. This is one of the important feature. Timers are two. Then how many interrupt sources? There are 6 interrupt sources. Now see, out of the 6 interrupt sources, there will be 2 external interrupt sources. There will be 4 internal interrupt sources as well. Now what is difference between external interrupt, internal interrupt, that we'll discuss as we go on. So these are what important features of the 8051, and this is what the important, you can say this is the block diagram of 8051. Now see what Intel has done from it after 8051 they launched 8052.